Hello everyone, my name is VP Nguyen and I'm currently an assistant professor of computer science and engineering at UT Arlington. Today I'm going to discuss with you some of the research opportunities that Shijia group at UC Merced and I are exploring. And by the way, we are looking for highly motivated PhD students, so if you are interested, please let us know. With the development of IoT, many devices with sensing ability enter human life, and there will be 21.5 billion of them in the next 5 years. Among the three main components of most recent intelligent systems, including sensing, computing, and communications, we have been focusing on develop reliable and novel sensing solutions to monitor human health conditions and their living environments. The recent human sensing modality can be divided into two main categories, including body sensing or wearable sensing and infrastructure sensing or device-free sensing. The wearable sensing refer to systems that can be worn by user at different form factor to monitor human health and activities. These are a few examples of our recent publications in the mobile community. The discussion that I'm about to give are the summary of our own experience working on this area. We also focus on making infrastructure become sensors to monitor different levels of human activities. From our experience, we found that the current wearable and infrastructure sensing solutions have the following limitations. Device-free sensor can provide very high temporal resolution sensing. We now can capture signal from human brain, human muscle, blood pressure, oxygen level, glucose level, and so on using wearable device. However, these sensors have a very low spatial resolution. For example, a brain sensor needs to place very close to the human head in order to capture a reliable signal. On the other hand, device-free sensors provide a very good spatial resolutions. We can send multiple things in the environment at the same time, but they have very low temporal resolutions. So device-free sensor can often only can capture big events such as running, sitting, and walking, but they cannot capture the events that require advanced sensing solutions like wearable. So we envision that the future collaborative sensing solutions, which combine the best characteristic of human and device-free sensor, will help us building solutions that obtain high level of spatial and temporal sensing result. Before discussing some research opportunity that we have identified, let's discuss the research challenge related to wearable and infrastructure sensing that we need to overcome. Recent exciting wearable systems such as Emotive, NeuroSky, BrainLink, Muse, Wearable, Neuron can capture some of complex activity by monitoring human physiological and biological signals for different applications. However, these systems can only work reliably in static and semi-static environments like sleeping, meditating, sitting, and so on. They cannot perform well under mobility settings environments such as walking, running, or exercising. Recent device-free sensing systems also obtain another level of sensitivities where some of the device can capture a certain level of human vital sign signal, such as breathing behavior, heart rate, and so on. However, these device-free sensors still cannot capture complex signal from human bodies, such as brainwave, muscle activity, and so on, like what wearable device can capture. So there's a lot of room for sensing data quality improvement. So device-free sensing systems are often static and semi-static. They usually have a limitation in sensing range, and often it is room level. So wearable device can be used to establish the link that connect these room level sensors together. However, there are a few challenges preventing us from realizing that idea. The first challenge is that there's no reliable network protocol that connects wearable and device-free sensor together. Secondly, wearable device has a limit computational resource and power. The overhead and benefits of such collaborative device-free wearable sensing are unclear. Okay. And developing sensing modality is often limited by datasets, especially for those indirect sensing modality. How can we obtain sufficient amount of data that um, are reliable for building a sensing solution uh, when the user is keep moving from one place to another? How can we integrating them? How can we combine them and to build a large data set? That's something that we need to work on. And the trade-off between lowering the system cost and enhancing the sensing data quality is challenging for IoT sensing system. For perversions and room scale systems, the high cost would make the system difficult to be affordable by individual or family. For city or area scale systems, high cost device make it difficult to achieve a high density or large coverage of the deployment. We identify a few opportunities in building some novel collaborative device-free and wearable research in the future. First of all, in the collaborative sensing scenario, temporal knowledge obtained from high fidelity sensing data from the wearable sensor can be used to improve or enhance the device-free sensing capability. Specifically, uh, wearable device can be used to characterize the background noise at different environments and transfer this knowledge into device-free systems. For example, a clean EMG, EEG, EOG signal captured by wearable device can be used to train the vision-based sensing system to enable human emotion monitoring. Also, in multi-person scenarios such as family gatherings, students in the class, people in the meetings, wearable device can provide its identity to surroundings device sensor, allowing this infrastructure sensor to be able to identify patterns and extract signal from individual. On the other hand, the wearable device can exploit sensing information provided by device-free system to remove the noise. For example, device-free sensing system can monitor environmental noise such as magnetic field noise, electric field noise, acoustic noise, and transfer that knowledge to the wearable device for configurations. Also, the ability to localize user location at centimeter level using some of the recent device-free systems such as light-based, Wi-Fi-based, millimeter wave-based, ultrasound-based localization technique would benefit wearable device a lot in multi-person sensing scenario. And what it will be another direction is to establish a cross-scale, cross-modality information associations where the model of collaborative, device-free, and wearable sensing from one place can be used to infer the relationship at the other place where um, data is not sufficient. Both device-free sensing system and wearable system are highly impacted by the environment noise. The question is, how can we leverage the knowledge obtained from different sensing modality to train and build a universal noise model that can be applicable on both sensing solutions and improve the general sensing performance. So the last direction that we would like to explore is to establish a secure and privacy preserving platform that associating the sensing data collected from the two sensing modality. As an example, instead of reporting a raw data to the clouds, the two sensing systems can communicate to each other, summarize the collected information before sending the summary to the cloud. Or we can try to establish a secure communication channel that only happens at the room level. The user and a wearable device going out of the environment, that communication channel will be automatically destroyed. And also another direction we found is that a location-based approach should be developed to limit the remote access. And these are kind of the direction that we have been looking at right now. We are open to new ideas, comments, and contributions, and also collaborations. Thank you.